factoring trinomials. So first let's revise the squares of these two binomials. So x plus y squared is x squared plus 2xy plus y squared, and x minus y squared is x squared minus 2xy plus y squared. So we can use these two squares of binomials to factor certain trinomials. So let's see an example. So x squared plus 10x plus 25. So we can write the middle term 10 as 2 times 5, and 5 squares to 25. So this simplifies to x squared plus 2 times 5x plus 5 squared. So this looks like the square of the first binomial, where y is 5. So this simplifies to x plus 5 squared. Okay, so let's take another example. X squared minus 8x plus 16. So we can also write the middle term as minus 2 times 4x, and we can square 4 to get 16. So this is x squared minus 2 times 4 times x plus 4 squared, and this looks like the square of the second binomial, where y is 4. So this simplifies to x minus 4 squared. But most trinomials cannot be easily factored into the squares of these two binomials. So what should we do? So first we will look at an intuitive method, then we'll look at a trick which simplifies the process. So let's consider x squared minus 3x plus 2. So we know that we're looking for two binomials which, when we multiply, gives us back x squared minus 3x plus 2. So let's write that as x plus d times x plus e. And if we distribute, we will get x squared plus d plus e times x plus de. Now the problem reduces to finding these two numbers d and e such that their product is 2 and their sum is minus 3. So one solution is d is equal to minus 2 and e is equal to minus 1. Or you can also take d is equal to minus 1 and e is equal to minus 2. So x squared minus 3x plus 2 factors to x minus 2 times x minus 1. So let's take another example. X squared minus x minus 6. So we know that we look for two binomials such that the two numbers d and e, their product is minus 6, and when we add them we get minus 1. So one solution is d is equal to minus 3 and e is equal to 2, or you can also take the vice versa. So x squared minus x minus 6 simplifies to x minus 3 times x plus 2. Okay, so in the first two examples the coefficient of x squared is 1, but what if, we get a trinomial where the coefficient is different from 1? So we know that we get the leading term x squared when we multiply the first term in the first binomial and the first term in the second binomial. So one intuitive approach is to incorporate this coefficient in one of the two first terms of the two binomials. So one choice is we can say 4x plus d times x plus e, or you could have also said x plus d times 4x plus e. Now let's distribute this. So we get 4x squared plus 4e plus d times x plus de. Now the problem simplifies to finding these two numbers d and e such that their product is minus 3 and 4e plus d is 1. So one solution is d is equal to minus 3 and e is equal to 1. So 4 times 1, which is 4, plus minus 3, which is 1. So 4x squared plus x minus 3 factors to 4x minus 3 times x plus 1. So let's look at a trick which simplifies this process. So 4x squared plus x minus 3 can also be factored by first finding the two factors of 4 times minus 3, which is minus 12, which add up to 1. So those numbers are 4 and minus 3. So 4x squared plus x minus 3 is 4x squared plus 4x minus 3x minus 3. Now we can factor out the GCF of the first two and the GCF of the last two. So the GCF of the first two is 4x, so we have 4x times x plus 1 minus 3 times x plus 1. And the GCF now is x plus 1, so we have 4x minus 3 times x plus 1. So this is a much faster way of finding the factors. Okay, so let's take example. So what about 2x squared plus 9x minus 5? So we look for two factors of 2 times minus 5 minus 10, which add up to 9. So those numbers are 10 and minus 1. So we have 2x squared plus 10x minus x minus 5. So the GCF of the first two is 2x. So let's factor that out. And we have 2x times x plus 5. And we'll factor out minus 1 from the last two. So now the GCF is x plus 5. So this is equal to 2x minus 1 times x plus 5. So another example. What about 6x squared plus 7x minus 3? So now we look for two factors of 6 times minus 3, which is minus 8, that add up to 7. So 9 and minus 2 are those two numbers. So we have 6x squared plus 9x minus 2x minus 3. So the GCF of the first two is 3x. So let's factor that. So we have 3x times 2x plus 1, 2x plus 3, and we will factor out minus 1 from the last two. So we have 3x times 2x plus 3 minus 1 times 2x plus 3. So now the GCF is 2x plus 3. So this is 3x minus 1 times 2x plus 3. So another example. What about 8x to the power 4 minus 2x squared minus 3? Well, this is different as in the degree of this polynomial is 4. So what should we do? So one thing we can do is we can apply substitution of variables. So and say let y be x squared. Then this 4th degree polynomial becomes a second degree polynomial where 8x squared, 8x to the power 4 minus 2x squared minus 3 is 8 y squared minus 2y minus 3. Now the problem simplifies to finding the two factors of 8 times minus 3 minus 24, which add up to minus 2. So those numbers are minus 6 and 4. So now let's rewrite this as 8y squared minus 6y plus 4y minus 3. So we'll factor out 2y from the first two, and we'll have 2y times 4y minus 3, and we'll factor out 1 from the last two, and we'll have plus 1 times 4y minus 3, and the GCF of these two terms is 4y minus 3, so this is equal to 2y plus 1 times 4y minus 3. Now we can substitute x back, and we'll get we'll replace y with x squared, and we'll get 4x x squared minus 3 times 2x squared plus 1. I hope you enjoyed it. Thank you.